So curiously, I'm really not getting much there. I can zoom all the way down to 50 millivolts and I don't get nothing. It shows up on the scope anyway, in a reliable fashion. But what I am noting is if I go out to 2 milliseconds and half a volt per division, I'm getting a pretty wide variety. I mean, this is 263 hertz. That very clearly would not be 263 hertz, but it's all over the place when I'm actually holding the button down. So it's like a bunch of random spikes. And the spikes are always in that one direction, curiously enough. They don't go negative. They don't go down on the scope. They always stay at the zero line or above, which is another curiosity. So this implies that there's not enough inductance to pick up the AC modulation of the field, and instead it's probably just picking up the ions, getting up to some point before it's able to interact, and then it interacts, which shorts itself out, and nulls it back to zero maybe, or something like that. So, I mean, that's this coil. 10 gauge coil. So that one is all over the map, and it's at much lower voltage amplitudes, half a volt, maybe 2 or 3 volts peak. If I go up to 1 volt division, I can't even see those spikes that you're seeing now with the half volt division. So, yep. The good news is it does appear to change with whatever's in there. So, I mean, that coil is going to be in the not even in the millihenries. It'll be in the microhenries range, maybe 100 microhenries or so, somewhere in there. I have to get the LCR meter out to measure it and to see for sure. But, yeah, that's interesting to note. So, evidently it does change with whatever's in there, based upon whatever's in there. It takes up about the same space, about an inch smaller diameter coil, and maybe a sixth as much